Hi, this is the first part of my Syslog-ng tutorial. Last time we learned about enriching log messages using Syslog-ng. Today we learn about how to send log messages to Elasticsearch. Originally, the Elasticsearch destination of Syslog-ng was implemented in Java. It was a bit resource-hungry, but it worked well and it was also fast. Unfortunately, however, this implementation could not be included in the Linux distributions, as the build process used tools that were unavailable in distributions and downloaded jar files instead of compiling everything from the source. Using Java was also problematic because the included drivers had to be updated after each Elasticsearch release. As such, uh, there is now another implementation of the Elasticsearch destination that does not need Java. Actually, it's a configuration snippet in the Syslog-ng configuration library. It is a wrapper around the generic HTTP destination driver, which is implemented in C. It is not just the Elasticsearch destination that uses it, though Slack, Sumo Logic, Telegram, and a number of other destinations are built on the HTTP destination. Note that while I keep referring to this driver as Elasticsearch destination, you can also use it with several other software utilizing the Elasticsearch API, such as Opensearch, Zinc, Humio, and probably more. In this part of the Syslog-ng tutorial, we use a configuration similar to what we used when we talked about log enrichment. However, there are a few changes. The first one is that instead of a JSON file, Syslog-ng sends log messages to Elasticsearch. Here you can see an Elasticsearch destination based on the Elasticsearch HTTP driver. There might be minor differences in the URL or template when sending logs to Opensearch, Zinc, or Humio. You can find configuration examples in the Syslog-ng blog. The index in the database name, the index is the database name where Syslog-ng sends the log messages. Type was used for Elasticsearch 6 and earlier. It is still a mandatory parameter for the driver in Syslog-ng, but for 7 and later versions, you have to keep this parameter empty. User and password identify the user if security is enabled. URL takes multiple parameters, and that way Syslog-ng can perform load balancing among multiple Elasticsearch nodes. The template is almost the same as we have seen in the previous part of my Syslog-ng tutorial. We talked about templates and template functions earlier, so here I only want to emphasize one key difference. There are no new lines at the end of the template. While new lines make text files easier to read, they break Elasticsearch. The GIP parser of Syslog-ng stores longitude and latitude information into two separate name value pairs. Kibana expects them in a single name value pair and does not like empty values. As such, this rewrite rule makes sure that Syslog-ng sends geographical location information in the expected format and only if the related information exists. For certain data types, like geographical coordinates, Elasticsearch needs mapping. Mapping is telling Elasticsearch that a given name value pair contains a certain data type. This mapping matches the example Syslog-ng configuration in this tutorial and sets the type to GeoPoint. Note that mapping has slight differences between various Elasticsearch versions, so the following example might need some small modifications for the versions you use. This example configuration collects both local log messages and IP tables logs over the network. It parses the IP tables logs and adds geographical information to the source IP addresses using the GIP parser. Finally, it stores both the local log messages and the parsed IP tables logs into Elasticsearch. As usual, the configuration starts with the version number declaration and including the Syslog-ng configuration library. It is followed by a source for local log messages, a file destination, and the log statement which connects the two together. IP tables, IP tables logs, uh, IP tables log messages are collected by a TCP source. These log files um, are first parsed by key equals value parser, then by the GIP parser. You can learn more about these in the previous part of my tutorial. The rewrite rule creates a name value pair by combining the longitude and latitude information if they are not empty. The resulting format complies with the expectation of Elasticsearch and Kibana. The Elasticsearch HTTP destination stores log messages into an Elasticsearch database. The log statement starts with two sources, one for the local log messages, while the other one is the network source collecting IP tables logs. Parsing is only necessary for the logs arriving to the network source, so there is an if statement which is matching on logs coming from the TCP source. Matching logs are parsed and rewritten uh, by the parsers and the rewrite rule uh, defined earlier. Finally, all log messages are sent to Elasticsearch. Flex flow control at the end means that if the destination is slow, Syslog-ng slows down receiving the log messages. This works with a TCP source or when reading a file. However, it does not work with UDP, as Syslog-ng has no way of letting the sending side know that the message rate is too high. Here are some IP tables sample logs. These are good enough for testing, however, using some real-life IP tables logs are a lot more fun. Refer to the previous part of the tutorial on how to send these logs to Syslog-ng. This map shows IP addresses on a map. It was created with Syslog-ng using the GIP parser to turn IP addresses into geographical locations. Then I used Kibana for display. Talking to security professionals, I was advised that these maps do not have much practical value. However, people in upper management love visualizations, and showing maps based on your firewall logs might help you to get some additional funding for your information security budget. If you have any questions or comments, leave a comment on YouTube or reach out to me on Twitter or Mastodon.